All right, so I'm going to go over a couple different things about parallel and perpendicular lines and their linear equations. So let's start with parallel. I wanted to go over the symbol for parallel lines. So let's say, you have all the examples right here, right? But I'll just draw a couple too. So let's say that we have two lines that are parallel. We'll call this AB and CD. Okay. Now, the cool thing about parallel lines, they will never, ever intersect. Okay, so that's the key thing to remember about parallel lines. They will never meet, right? The distance between them is equal their entire length. Okay, so when we're describing parallel lines, so let's say we know that AB and CD are parallel, and we're asked to write that out, we would say AB, about line AB, is parallel to line CD. So this symbol right here, the two dashes, two lines. Now sometimes you'll see it like straight up and down or slanted, okay? But that symbol, that means parallel. So if you ever see something like XY / AB, that means that XY and AB are parallel, okay? Now, another way you'll see it notated on the actual lines. So again, let's say that AB and CD are parallel right here, okay? If we want to indicate on the lines that they are parallel, we use these little things that they're called feathers, okay? They're like little arrowheads, basically. So if we know that AB and CD are parallel, we would just put a little arrow on both of them. Okay, but in the case that we have more than one parallel set of parallel lines, so here we have line AB, line CD, right? AB, CD. We also have AC and BD, right? In this case, because AB and CD are parallel, we do have, let me change the color here. We do have feather markers here because those two lines are parallel, but AC and BD are also parallel. And we don't want to use the same one arrowhead because that would mean that AC and BD are parallel to AB and CD, which they're not, right? So instead of using just one set of that arrowhead feather symbol, you would use two, right? So if there's one set of parallel lines, you can just use the one arrowhead, right? The one feather. If there's two sets, you can use one on the first one and two on the second one. The third set then would have three, and etc. Okay, so that's the notation for parallel lines. Now let's go over perpendicular lines. Okay, so perpendicular lines. These are lines that intersect to form right angles. So that's the key thing with perpendicular lines. They're going to have a right angle. So let's say that we have, pretend this is a rectangle. Let's say that we have this rectangle. We know that rectangles have right angles, okay? So to notate that they're perpendicular, so let's say that this line, AB, and this is AC here. To notate that those are perpendicular lines, right, that they intersect at a right angle. Everyone see that? You use the little right angle symbol. Okay. You could also say, if we were to just write it out, you could say that, let's actually call this line X. We'll call this line Y, right? Kind of like a graph. So ignore this. So if we want to write out that line X is perpendicular to line Y, we could write x is perpendicular to line y. Now sometimes you'll see just this symbol, and sometimes you'll see this with the little right angle symbol. Okay, but they both mean perpendicular. Long word. Okay. All right. Now, if we just have a shape, right, and we want to indicate on the lines that they're perpendicular, again, we would just use the right angle symbol. Okay, so this is showing that this line right here, we'll call that again line X and line Y. Line X is perpendicular to line Y. Okay, all right. Congruent. Yeah, let's talk about congruency. Congruent lines are basically just line segments or lines that are equal in length. Okay, so let's use rainbow again. Let's say we have two lines. We'll call this AZ, and we'll call this BK for fun. Let's say that we know AZ is, we'll say, 5 centimeters, and we also know that BK is 5 centimeters. Okay, so we know already that these are congruent lines because they're equal in length, right? But how do we notate that? If we're notating it on the actual line, you can use little tick marks, basically. So we could draw one little tick mark on both of them. That would show that they're parallel, or sorry, not parallel, congruent, although they do look parallel too. If we were to write that out, though, we could say that line AB, or line segment AB, is congruent to, or sorry, AZ is congruent to BK. So this symbol right here, the equal sign with the little tilde, the little wavy line, that means congruent, or equal in length. Okay? Now, if there's more than one set of congruent segments on like a shape or in a graph or something, so let's say that we have that kind of shape again. Now let's say that this is line segment X, this is Y, this is A, this is B. Sorry, I don't know why that keeps doing that. Okay. So let's say that we know that A and B are congruent, and we know that X and Y are congruent, but they are not congruent to each other. So X is not congruent to A or B, and Y is not congruent to A or B. So how we could actually notate that on the drawing, if we know that A and B are equal or congruent, we could use the one tick mark there. But we couldn't use just one tick mark on X and Y because that would mean that they're also congruent to A and B, right? So instead, on X and Y, we could use 2 tick marks. So there we're saying that X and Y are equal to each other, but they are not equal to A and B. And same with A and B, right? A and B are equal to each other, but they're not equal to X and Y. So it's kind of the same thing like we were talking about with the sets of parallel lines, right? If there's one set, you use the one feather. If there's 2 sets, the second one you'll use a second feather. The third set, you use 3 feathers, right? Same with congruent lines. So the first set of congruent lines, you can use 1 tick mark. Second set, you can use 2 tick marks. Third set, you can use 3 tick marks. Okay? Okay, now that we have the symbols down, actually let's go over one more example really quick. Let's say that we're going to use green. Let's say I have this lovely shape here. Now, we know that this is a rectangle, okay? Rectangles have 4 right angles. Okay, 4 right angles. And they also have the fact that opposite sides are both parallel and congruent. Okay, so let's say that you're given this shape and you're asked to notate on the shape that there's parallel lines, there's perpendicular lines, and they're congruent. Okay, so how do we do that? So let's use purple. So to show that they're perpendicular, we'll use purple. Okay, and then we'll use, let's see, blue for parallel symbols, and then yellow. Let's use yellow. Yellow for congruent. Okay, so starting with perpendicular. Again, perpendicular lines are lines that intersect at a right angle, right? And to show that on the figure, we would draw our little right angle symbols. Okay, so this is saying that, let me get back to green. This line right here is perpendicular to this one. This one is perpendicular to this one. This is perpendicular to this, and this is perpendicular to this. Okay, so we have 4 right angles, 4 sets of perpendicular lines. Okay. Parallel. How to mark that they're parallel. So let's say that we know for sure, we're told that, let me get back to green. Green. Okay. Let's say that we are told that this line and this line are parallel, right? How do we indicate that? Okay. Now, remember, if you look back to our parallel line examples, we use the feathers. Okay. So on this lovely shape, if we want to indicate that those two sides are parallel lines, we're going to use those feather marks. It doesn't really matter if they're pointing down or up, right, or left, right, as long as it's same direction. Okay. And let's say that we're also told that this line and this line are parallel, right? How do we indicate that? We can't use one little feather, because that would mean that it's also parallel to the other two sides, which they're definitely not, right? They're perpendicular. So instead of using one little feather, we use 2. So that is saying that this side is parallel to this side. Okay. And last but not least, congruent. We're given the measurements here, right? So these two sides are 5 in length. These two sides are 10 in length. So we know that they're congruent, right? They're equal in length, the opposite sides. So how do we actually mark that, though? Again, with congruency, you would use those little tick marks. So we could say that this line right here is congruent to this line. And we don't want to use just one tick mark on the other sides, because that would mean that they are also 10 in length, which they're not, right? So on the other side, I'm going to use 2 tick marks. So this is indicating that the 5 and the 5 are equal in length, and the 10 and the 10 are equal in length. And there we go for our lovely rectangle example. Now let's talk about parallel and perpendicular line equations. Now, parallel and perpendicular lines, they're going to be, at least in this example, we're going to be talking about linear equations. Okay. Now, parallel lines will always be linear, right? They're straight. Okay. Actually, I don't want to use black. Okay. So in this particular part in the class, we're only talking about linear lines when we're talking about parallel equations and perpendicular. Okay, linear lines, meaning they're straight. Okay, they don't curve at all. Straight. I love the word straight. Was not straight. Okay. All right, so parallel equations. So the important thing with parallel equations is that other than they're linear lines, right? The important things with parallel, I'm going to switch the color here. Whoa, sorry. Okay. The important thing to remember with parallel lines is that they have equal slope, but they do not have the same y-intercept. Intercept. There we go. Okay. So, for example, if you look closely at this little graph guy right here. Okay, or graph lady. Okay. So you'll notice we have the two lines and their equations. Okay. You'll notice that one of them is y equals 1/2 x minus 3. The other is y equals 1/2 x minus 1. The similar thing here then is the slope, right? The slopes are equal. The y-intercepts are not equal, right? So that would tell us that these are parallel lines. And if you don't trust me that all parallel lines have the same slope and different y-intercepts, go ahead and just try graphing a couple different parallel line sets. Okay, they'll all have the same slope. Parallel lines will always have the same slope and different y-intercepts. If the y-intercepts are actually the same and the slope is the same, you would have two lines that overlap. Right, they're right on top of each other. I'm trying to make those right on top of each other. There we go. So they wouldn't necessarily be parallel, right? They have an infinite amount of intersections, right? So they're not parallel lines because parallel lines never meet. Okay, let's talk about perpendicular lines. I almost started singing a song, but I'm not going to. Okay, perpendicular. Almost stopped there. Perpendicular line equations. Okay. Perpendicular line equations are going to be different than parallel lines. And you're like, yeah, obviously. But what's cool about them, if we zoom in on this lovely graph, we have our two different equations here, right? Y equals 3/4 x plus 5, and y equals negative 4/3 x minus 6. So kind of forget about the y-intercepts for a second. What do we notice about the two slopes? One of them is 4/3 and the other one is 3/4. And the other one is negative 4/3. Okay, so you may notice that one of them is negative and one of them is positive. You may also notice, because you are very keen observers, I almost couldn't think of that word, that these are reciprocals of each other, right? 4/3 and 3/4. Okay, so perpendicular lines are cool because, whoa, didn't mean to do that. Are cool because their slopes are actually opposite or negative reciprocals of each other. Okay, so that's the important thing with perpendicular lines. So their slopes are opposite. By opposite, I mean like their sign, so positive and negative. So it's going to be a negative and reciprocal. Now, what I mean by negative there, I don't mean that it's always going to be negative. Okay, I mean when we are asked to find the perpendicular slope of a line, so let's say we're given y equals 2x plus 1. If we want to find the slope of a line that's perpendicular to this one, the first thing you're going to do So step 1, you're going to multiply. Actually, let's start with the other step. Start with step 2. No, we'll still call it step 1. So step 1, you're actually going to divide 1, and it doesn't have to do with y-intercept, just always divide the number 1 by the slope. So here, instead of 2, we would have 1 divided by 2, or 1 over 2, or 1/2, right? Which is the reciprocal of 2 over 1, right? So divide 1 by the slope just basically means find the reciprocal, okay? The second step would be to multiply that number by -1. Okay, so instead of 1/2 times -1 would be -1/2. Okay, so again, parallel lines are going to have equal slope, different y-intercept. Perpendicular lines, their slopes are going to be opposite or negative reciprocals of each other. Okay, their y-intercepts could actually be equal, but they don't have to